Okay folks, in this lesson we discuss displacement mapping and also subdivision. We are going to be using a simple cube and a simple plane object for this lesson. Let me just convert this cube to a polygonal object. Also you can use it at its primitive state, but let's convert it for now. Let me just go to create menu in the material manager, Arnold, surface, and create a brand new utility shader and apply it to the cube. Let me just run the IPR and open up the utility shader, change the shade mode to Lambert and change the overlay mode to polywire. Now we can see the edges of our geometry. Right click on the cube, go to C4D28 tags and add an Arnold parameter tag. Go to the subdivision tab. First we have the subdivision type, which is none, linear, and cat-Clark. We have iteration here, which specifies how many times the mesh should be subdivided. When the type is set to none, there would be no subdivision. Obviously, you can see the iteration is grayed out. When set to linear, as you increase the number of iterations, you are adding more polygons to your geometry without changing or compromising the shape of the geometry. Now when the iteration is set to 0, there would be no subdivision, and when I increase it to 1, we have generated 4 faces of each face, and when I increase it, the iteration to 2, we have quadrupled the number of polygons again. Go to 3, we have quadrupled the number of faces again. So each time you increase the iteration by 1, you have 4 times more polys compared to before. So imagine if you have, for example, a geometry with 250,000 face and you just increase the iteration by 1, you are going to have a geometry that has 1 million face. So you really need to be careful when you increase this number. But in linear mode or type, you keep the original shape of the object. Let's change the subdivision type from linear to cat-Clark, and immediately we have a sphere instead of a cube. The Catmull-Clark algorithm is used to create smooth surfaces by recursive subdivision surface modeling. So as I increase the iteration, I am not only adding more geometry, I also make the geometry rounder and smoother. Let's set the iteration to 3 here. Then we have adaptive metric, which allows us to have some level of adaptiveness in our subdivision. So for example, based on how close or far we are away from our object, we can have more or less iteration applied automatically. At the moment, it's set to auto, and as I increase my pixel error to 60 and run the IPR again, you can see we have smaller amount of polys if I get away from my cube, because we are far away from our cube and we don't possibly need as much detail as before, so we get less faces, and we're gonna have obviously smaller iteration values and therefore less polys. If I get closer to my cube and run the IPR again, we are gonna have more iterations and polys again. And as we decrease the adaptive error value, we are gradually decreasing the adaptiveness, and at 0 we have no adaptiveness no matter what. Now let me get back to the camera again. Also, we have 2 adaptive modes besides auto. We got edge length and flatness. When set to flatness, the curvature of the mesh in pixels is the feature used to choose the adaptive subdivision level. When using edge length, the length of the polygon edges in pixel is used. When set to auto, flatness will be used when no displacement map is applied, and edge length will be used when a displacement map is applied to the mesh. Then there is adaptive space with raster and object modes. Raster corresponds to adaptive subdivision in raster space, and object corresponds to adaptive subdivision in object space. When instancing, you should use the object mode, and when you have only one object, the raster mode will work. You probably don't need to change this option unless you have some instancing going on in the scene. Also, you can read about these options more in the Arnold support website. We have UV smoothing, which controls the algorithm used to smooth the UV vertices in the mesh when you are subdividing it. Pin corners pins the four corners of our UV, and the rest of the UV might move as we subdivide our mesh. Pin border will pin all the edges of our UV. Linear will pin everything. So the UV will stay as it was before subdividing, and smooth will basically move the UV vertices as we subdivide our mesh. No pinning basically in this mode. Also, if you notice any faceting happened in your specular highlights when you have anisotropy, you can enable smooth tangents to get rid of the faceted look by enabling this smooth tangents option. Now that we have this foundation about subdivision, let's discuss displacement mapping and how to achieve it in Arnold for Cinema 4D. Displacement mapping allows you to create real geometric details based on a texture. The difference between displacement mapping and bump mapping is bump mapping was just an illusion. We wouldn't alter the geometry, but displacement mapping actually creates and alters the geometry. Now let me show you how to add displacement mapping to your shader. Let's start by creating a new standard surface shader and renaming it to displacement map or whatever. Now open it up and open the network editor for this shader. And let me just zero out the specular weight. As you can see down here, we have this Arnold displacement port. On the left side, let's search for displacement. We have two displacement nodes, normal and vector displacement nodes. Normal displacement map is the more traditional one when you have a grayscale image and you want to add displacement based on that grayscale texture. But vector displacement can also displace the mesh in different directions besides only up and down that we have with normal displacement mapping. Let me drag a normal displacement node for now and connect it to the displacement port. The next thing would be to define the grayscale image which we want to drive our displacement mapping with. So let's drag an image node and load this displacement map, which is a 32-bit grayscale image. Now connect the output of the image to the displacement input of the normal displacement node. Also apply the displacement shader to the cube and run the IPR. The amount of displacement is too much, so that's why we see nothing relative in our render. Let me select the normal displacement node and decrease its scale, which is the amount of displacement. Let me probably 0.1. Obviously we don't have enough subdivision to get enough detail, so select the Arnold parameters tag and increase the iteration to about 6. I can increase the iteration number to get more detail, or decrease it to decrease the overall detail. Now let's set it back to 6. If I want to preserve the cubical shape of my base geometry, I can change the subdivision type to linear. When we do that, there is something wrong with the displacement mapping, as you can see. If you go to your displacement tab of the Arnold parameter tag, you have a parameter called bound padding. Padding defines how much to extend the bounding box of the object so that it can include any additional displacements coming from the displacement shader. So when the padding is set to 0 because we don't have big enough bounding box, we see this artifact in our render. By increasing the padding and extending the bounding box of our geometry, we will be able to get our displacements mapping the way it's supposed to be. And use this value sparingly. When 1 works, never go to 2. That will increase your render time. Now if I get back to my shader network editor and select the normal displacement node, let's take a look at this parameter. Here we have scale, which controls the amount of displacement. So if I go to something like 0.2 here, we're gonna get a larger displacement map. Also, you can use negative values, which will invert the effect of displacement. Let's use, okay, let's maybe something like 0.05 would be enough for here. We have scalar 0 value, which is applied as a shift to the displacement amount. It defines the value of the displacement map that is considered to be 0 displacement. By default, it is set to 0, so the black values of the texture are not going to get any displacement, so 0 displacement, and everything brighter is going to be displaced to the outward direction. When set to 0.5, 50% gray will be the zero displacement. Darker values in the texture will be displaced inward and brighter values will be displaced outward. And when set to 1, white pixels will have zero displacement and darker values will be displaced inward. Let's set the scalar value to 0 again. Let's select the Arnold parameter tag applied to our cube and see what other displacement related parameters we have. There's this height, which is like the scale value in our shader, and it controls the amount of displacements mapping in conjunction with the scale value. We discussed padding. We have another scalar 0 value which works like the one we have in the shader. I recommend not to use this scalar 0 value and instead use the one in the normal displacement node. We have auto bump, and as soon as I enable it, we get more detail. Auto bump puts the high frequencies of a displacement map into the bump attribute so that you do not need as many subdivision iteration values. And I suggest to have it turned on to get higher quality displacement mapping, especially with normal displacement mapping. Also, we have this vector displacement node. So let me hide my cube object and unhide this plane, and create a new Arnold standard surface shader and rename it to something like vector displacement or whatever. And let's open its network editor and search for the displacement map and drag a vector displacement node to the work area and connect its output to Arnold displacement port. By the way, if you don't see this port, simply click on the red corner of the main group and you can find all the available ports including Arnold displacement. Simply click on it and it will be added. Now let me control drag the current image node and load this ear texture and connect it to the vector displacement attribute of the vector displacement node. Now let's apply this material to the plane object and run the IPR. There is nothing particular in the render. Let me stop the IPR and select the plane and convert it to a polygonal object by pressing C. Add an Arnold parameter, go to the Subdivision tab and change the type to Cat Clark and increase the iteration maybe to about 5 for now. Now we are ready to see some displacement mapping, but if I run the IPR we still get nothing. Let me just get back to the network editor and see what is going on. We mentioned the difference between normal and vector displacement. In normal displacement, we only have two directions, up and down. So we can raise the geometry or lower it, but we cannot move it in any other direction. But with vector displacement, we can actually move our geometry in different directions. Let me just select my vector displacement node and change the vector space to tangent, because that's the way I generated this ear displacement texture, and change the order to X, Z, Y. And reduce the scale to something like 0.3. Scale controls the amount of displacement mapping. Select the Arnold parameter tag as well, and under displacement, change the padding to 1. Now as you can see, we have a perfect ear geometry in our scene. Let's just discuss different parameters that we have in the vector displacement quickly. We have displacement, which is like the scalar 0 value in normal displacement node. We have this scale, which controls the amount of displacement map. Higher values obviously result in stronger displacement mapping. We have vector encoding, which is signed and absolute. Absolute is for 32 or 16-bit images, and signed is for 8-bit images. In this case, I have a 32-bit image, so I can use absolute node. Then there is vector space, world, object, or tangent. So based on how you generated the displacement texture originally, you can choose your desired coordinate space. We have tangent, which is the input attribute for connecting a tangent-based vector displacement map if you have something like that, and if you have generated it in your sculpting tool. You can change the channel order and flip different channels. I wouldn't be able to cover every little detail practically here, but I refer you back to this tutorial on our own website, which explains the workflow from scratch about how to generate vector displacement maps and how to apply them. It's called rendering displacement maps from Cinema 4D. So that is about subdivision and displacement mapping. See you in the next lesson.